with that out of the way, I'd like to thank everyone for coming here, and would like to introduce Wolf. Wolf is one of the best programmers that I know. He's the only programmer I know personally that has an IMDb credit for being in the movie Code Rush. He is a force of nature and one to be reckoned with when it comes to talking about technical topics. And tonight he will be talking about Jupyter Notebooks. So please take it away, Wolf.
Thanks very much. I'm going to share my screen. Can you guys see my screen?
We are seeing your screen.
Yeah. Okay. So here's what I'd like to ask. Craig, if anybody raises their hand and has a question, I can't see people. So if you would make it happen for me.
I will announce questions and I will call on folks as necessary.
That sounds
good. But if you do have a question, please use the raise hand feature down below. It's basically a little thing that looks like a hand, moderately so. Apparently they got the largest fingers known to man. But yes, please go ahead.
All right. We're looking at a Jupyter notebook right now, and I'm going to start talking about it. This notebook is a presentation about Jupyter for Mug on the 9th of August. I want you to know what I'm using. I'm using my M1 Mac Mini. It's running Monterey. I'm using Orion as my browser. I've listed the specific versions of the software that I'm using, and I will make sure that at the end of this presentation, Craig has both the notebook in notebook form and an HTML version of it so that it's easy to view. And I will also make the notebook be available on GitHub. So who am I? I'm Wolf. And for people on YouTube, yes, it's just Wolf. I'm a longtime software engineer. I'm curious about a lot of things. I'm passionate about a lot of things. I love to use these things and play with them. Things like Python and Vim and Conch and Tmux and Jupyter and SQLite and tons of things. In my day job, I write software that teaches kids to read. I don't get to use Jupyter Notebooks a whole lot in my main job, in my day job, but I have used them a little bit. They're super fun to play with. I don't know a lot, but I'm going to show you a few interesting things to get you excited about them. This presentation is a demonstration of the big features and issues with Jupyter. It's enough to point you in the right direction, but there's not enough time for me to go deep on any one thing. But feel free to ask questions as I speak, and there'll be time at the end to play around and make whatever you want happen in the notebook. The notebook is dynamic and interactive, so we're going to make things happen in it. This presentation is not a data science lecture. Jupyter is a data science tool. I am a software engineer, not a data scientist. So I don't know all the ins and outs of data science and how they most use Jupyter. I'm more student than expert, but I can get you moving. This isn't a programming how-to. It's not SQL training. It's just about Jupyter and the features and packages that work with Jupyter. What I'm going to talk about. I am going to talk about what a Jupyter Notebook is, what cells are. I'm going to talk a little bit about pandas and matplotlib, which are super important to data scientists. I'm going to talk about Jupytext, which is a cool thing that I use to convert back and forth between Jupyter and other formats. I'm going to talk about NB-convert, which does the same thing, but not automatically. I'm going to talk about building GUIs inside your notebook using IPy widgets. I'm going to talk about NB-viewer, which will show you a static view onto a notebook. GitHub has this built into it, and we're going to take a look at a notebook with that. I'm going to talk about SQL and reading it in and doing things with that. I'm going to talk about NB-dev, which is an entire environment that goes on top of notebooks that lets you do interactive, literate programming and build complete libraries and write books and the works. We're not going to watch it work, but I'm going to talk about it. And then I'm going to talk about how to install and run Jupyter, and we'll actually make an installation of Jupyter and make it run. So what is a Jupyter Notebook? A notebook is an interactive, live programming, cell-based interface to computation. It's like Mathematica. I don't know if you guys know about Mathematica. Do you remember Mathematica? Code, data, tests, and documentation are presented in little hunks that are called cells. And each cell can be individually executed, reordered, and set to be either code or markdown or raw uninterpreted data. It's either a playground or a literate program or a proving ground or all three, depending on how you treat it. Why should I care? You should care because Jupyter is fun. Jupyter will make programming fun again. If you've been writing long programs that take forever to compile and you don't get to see your results right away and you make a tiny change and you have to go through the build cycle again, change all that. With Jupyter, you can play with your code, run just small pieces of it, make a change and run it again, use the source level debugger, plot output with graphing packages, and build UI right here in the notebook. If you're working with data, you can do the exact same thing. You can play with your data, run computations on it or on just a fraction of your data, change some parameters, run it again. It is easy to play and it is fun to play. And Jupyter will bring back a little bit of the joy of programming to your work. So that's why I use it, because it's fun. So what's the difference between Jupyter Lab and Jupyter Notebooks? This is Jupyter Lab. Jupyter Lab has tabs and a sidebar and why will that not close? Okay, that closed. And metadata and everything. Whereas Jupyter Notebooks is just this notebook part and no tabs. So a Jupyter Lab has a notebook in it, and it's still the same format and extension that it's always had, which is JSON and IPyNB, respectively. But Lab is the thing that's getting all the attention these days. Lab is where the work is going. So when you install this, you want to install Jupyter Lab and run Jupyter Lab. And a Jupyter Notebook is just the thing inside Jupyter Lab. What is their history? Jupyter was inspired by Sage, which is a math program with cells that was open source and was inspired by Mathematica. Jupyter is built on top of IPython. So it started with IPython, but has grown to be so much more. Jupyter started life around 2014. That's all I'm going to say about the history of Jupyter, because I'm more interested in what it does right now. But if you care more about it, I can look back and I can give more notes. Jupyter is built on top of IPython. When you're using Python as your language, IPython is your kernel. IPython is a command line app that you use for some things. I have used it. It's like Python itself. Python is a command line app. If you just run Python, it starts up an interpreter that interprets your code one line at a time. IPython is like that, but with syntax highlighting and special formatting and variable lookup and help and a ton of things. Jupyter is built on top of IPython, but IPython is the terminal interface and Jupyter is the GUI interface. What you're looking at right now is a specific implementation of the notebook concept that runs as a client-server pair, where the notebook interface is the client and the language kernel is the server. And there's a ton of different kernels. The most popular is Python. Python is the native language of Jupyter, but you can use a ton of different kernels. In fact, I've got a bunch of kernels installed here. This isn't nearly all of them, but these are some. Jupyter actually stands for Julia, Python, and R. Those are the 3 languages that it started out supporting, and it has only grown since then. You can tell that this is a Python notebook because up here in the top right-hand corner, it says Python 3. Oops, don't click on that unless you want to change your kernel. All right. So right now you're looking at a Python notebook or else a slideshow, because a little bit later I'm going to generate a slideshow and we'll get back to this slide. But before I start, I'm going to bring up the command palette, because Jupyter has a command palette like most things. Shift-Command-C brings up the command palette, and I'm going to restart the kernel and clear all outputs. That means we're going to start with a brand new, nice, fresh, untouched notebook. Now let's talk about cells. Every one of these gray boxes is a cell. As you can see, I've started off with cells that are just documentation. They are markdown. And if I execute a markdown cell, it renders as the kind of thing that it is. If you look at this markdown cell right here, you can see examples of how markdown delimits the text. 2 stars around something you want to be bold. Tildes around something you want to be strike through. Underscores around something you want to be italic. Backticks around stuff that you want to be code. There's stuff for building links and quotes, and there's a bunch of stuff. Basically, it can do anything that HTML can do because it can include HTML, but it's supposed to be readable in its natural form. Here it is just plain markdown, and it's easy to read, not like HTML would be with all its tags. But when I actually render it, you can see the bold turns bold, the strike through turns strike through, the italic turns italic, the code is a piece of code, etc., etc. So using a particular kernel implies that code cells, which we haven't gotten to yet, are going to be interpreted as that language. Each notebook uses exactly 1 kernel, so not including magic, which I'm going to talk about in a little bit. The entire notebook is in that 1 language. You can tell what's in a cell by this drop-down menu. Right now, I'm in this cell. It's got a blue marker next to it. That's the cell I'm in. Clicking on it hides the cell or shows the cell. This cell has markdown in it. Cells that have code in them have brackets next to them that show the execution order of the cell. When you want to execute a cell, you can hit this play button right here in the top margin, the toolbar. So I've got this blue selected cell right now that is marked down, as you can see. If I hit play, it is going to render that 1 cell and move to the next cell. But I haven't been hitting play. I've been hitting Shift-Enter, which is a shortcut for execute and move to the next cell. So now we're finally on a code cell. As you can see, it says code here in the drop-down menu. And code cells run code. They do calculations. They run programs. I'm going to hit Shift-Enter, and we will see that the answer to 2 plus 2 is 4. And this is the first code cell that we have executed since we restarted the kernel. So it gets 1 as its execution number. This is the input cell that says what to do. This is the output cell that says the answer. When things have an answer, they get an output cell. When they just print standard out or standard error, they don't have output. They just have themselves. So now we're on the next cell. This cell ends with hello world. Whatever expression ends a cell is the result of that cell. So I'm going to hit Shift-Enter, and you can see the result of this cell is the string hello world. Now we're looking at another cell. This is Python. I assign the string wolf to a person, and then I use an F string in Python, which lets you do substitution. In JavaScript, you do this with backticks. I don't know how you do it in Perl, but maybe a Perl person will speak up in the chat. But this is going to print, and print is standard out. And standard out is not the result of a cell, it's the output. So it's printed outside of any cell. So when I hit return, there's a 3 input cell, but there's no 3 output cell. There's just hello wolf, and standard out is not the result of the cell, so it's printed outside of any cell. Now we're back to another markdown cell. The Python, since this is Python, is doing syntax highlighting. As you can see, the comments are highlighted, and the strings are highlighted, and the substitution is highlighted appropriately. It knows that it's Python and knows how to do things with Python. For instance, if I hit .l and then tab, I can autocomplete a function like lower. That'll take wolf from capital W-O-L-F to lowercase w-O-L-F. And then I can say count, and count counts the number of whatever letter I say next. So let's count the number of O's. Now if I hit Shift Enter on this cell, this has a result. The result is 1. That shows up in the result cell. And we're back to a markdown cell again. So standard out and standard error from the code cells above appear between the cells, not in them. Results appear in result cells. Standard output streams appear between the cells. And a little bit later, we're going to actually see standard error as well. But for now, let's do an actual Python import and see what version of Python we're running. Now, this does a print. Print goes to standard out. So this is not going to go into a result cell. It's going to go into output between the cells. And this says we're using Python 3.10.5, which is pretty good. It's basically the latest non-beta Python. We're up to 3.11, but with a beta. So I decided to use 3.10. All right, before I talked about magic. Magics come in 2 varieties. Start with a percent or a double percent. When you have something that's magic, it means something special to the kernel. Something weird happens. Something that's not straight Python, for instance. Something that is specific to that kernel. A single percent is a line magic. A double percent is a cell magic. So here's some cell magics. Percent JavaScript means run this in JavaScript. And what I'm going to do, first let me get this cell out of the way. What I'm going to do is first I'm going to open the Python console. Which I've already made big. Oh man, this is annoying. Maybe I won't do this. There we go. I'm going to clean it up. I'm going to show only the logs. And now I'm going to execute this hunk of JavaScript that does a console.log. And here you can see in as big as I can make it, but not big enough, look, I can mix in JavaScript. Here's a hunk of bash. Bash defines a variable, my variable, and it echoes a string that interpolates my variable. So let's execute that. Here's some bash. That's exactly what I expected. But a limitation of this cell magic is that each cell stands alone. So now my variable is not defined in this next cell. And if I hit return, I get no output because it echoes nothing. But if I was actually in a cell with bash as the kernel, I could execute this first cell, and then the second cell would already have my variable truly defined. Now, this weird stuff between the cells with the plus and the colon and the 1, that's because I have a weird bash prompt, which you'll get to see later. But that's why bash doesn't look quite right in my notebooks. All right, here's some Perl. This Perl is going to print the values 1 to 10, one number on each line. It uses map to do that. But since we're fooling around, let's see if we can do exactly the same thing using Python. So I've put in here three different ways to do this. With a for loop, using the map function, and using a list comprehension. So let's try the first thing. That printed 1 to 10 perfectly. Next, we'll use map. That printed 1 to 10 perfectly, but it does something annoying. I had to get the result of that and assign it to underscore because I didn't want the actual result to show up in a result cell. I just wanted it to print the output. And map produces a new array in Python. So the result of this is a list that is that array, and I didn't want that. Finally, we'll do it with a list comprehension. And that does the same thing. So map is interesting. Let's ask Python how map works. I can do that by saying just help map. And I find out that map is actually a class that acts like a function, and it turns out to be an iterator that does cool stuff. So what did we learn from all this? We learned that I like the for loop the best because the for loop is the shortest. It's the most direct, and it gets the job done the easiest without assigning anything to a special variable. So comparing like this, let me pick which one I thought was actually the best. And I like the for loop the best. Even though technically I should like the list comprehension the best, I don't. I like the for loop the best. So there's a full list of magics, which you can get by looking at this web page. Let me see if I can make it bigger. And there's a gazillion magics. Many, many, many magics. But I can actually list them here in Jupyter by executing this cell with the magic quick graph. Quick graph or magic are line magics that list the magics with a little bit of help each. So shift return, and this lists all the magics. And it is also long. But remember, I can collapse a cell by clicking on its little blue thing. All right. So those are the basics. Now, on to some data science things. Let's look at pandas and matplotlib. So pandas and matplotlib are things that data scientists use all the time. Pandas is a data management library that has tons of functions for fetching and putting data and manipulating it. And it has at least two main data types: data frames and series. Data frames are two-dimensional arrays of data, sometimes with labels and sometimes with column names. And series are the same thing except one-dimensional. So I'm going to import pandas. I'm going to use this deprecated function that's going to print some standard error for me, which I like. And then this is an assignment. An assignment is a statement. Statements don't have results. They just are what they are. So I then say the name of the data frame all by itself. That way we also get a result and we'll have a result cell. So now I'm going to execute this and make a data frame. This data frame is going to have 30 rows. This pink area here, that's standard error saying pandas.util.testing is deprecated. Use the functions in the public API. And then the result cell, 15, shows the first 5 and last 5 rows of this 4-column table. There's 30 rows total. Let's see what type this data frame variable is. And it is a pandas.core.frame.dataframe. It's exactly the thing that we wanted. Just like Bash has head and tail, Pandas has head and tail, and you can give it an n to say how much of the head or tail you want. The default is 5. If I just said head with nothing, in fact, let's do that. Head with nothing. I just get 5, but I want 7, so I'm going to say n equals 7. And now I got 7 of them instead of 5. But what if I want to see all 30 rows? Well, the thing that's controlling how many rows it shows is this display.maxRows setting. So I'm going to set it to be 30, but I'm only going to set it to be 30 for one block of code. And that block just has a single display in it. And also, at the same time, this data frame, I'm going to sort it by column C. So right now you see C starts with Y3SG, negative 1.1559, and then goes to 0.57, and then negative, and then negative, and then negative, and then 0, and then negative. We are going to have a new list that shows all 30 that are sorted by C, and it's going to display it in a result cell. So now it doesn't start with Y3. It starts with the most negative C, which is negative 2.4, and goes down to negative 0.0664, and then positive 0.2, and then goes up to 1.69. So this is sorted by C and shows all 30 frames. But if let me add a new cell. If I say, show that cell again, show the data frame again, sort values I equals C. It sorted by C. It did the same thing, but it didn't use that option setting that we had set for just that one block of code. So let's now extract from the data frame a series. We will get just column B from this data frame. And here it is, column B. It's got the names, starts with Y3, like it did here when we printed just the base data frame with no sorting. And let's find out the type of data frame sub B. So type data frame sub B is a series. A series is the one-dimensional view. You can see that the one-dimensional view has no column label because it's only one-dimensional, but does keep the labels for each row, which extracts from the right place. And you can see that the actual underlying data type is float 64. That's what's in the cells. Let's get the sum of that data frame slice, that series. That's going to add up all the values in the column all by itself. And the answer is 6. 6 and a little bit. So I've got this data frame. Let's actually turn it into a plot. Let's do something interesting with it. I'm going to import matplotlib. And this is total nonsense because this data frame is full of random data. But I'm going to make a bar plot from the data frame. And here it is. It starts with Y3, just like we looked at. It plots each of the 4 values, A, B, C, and D. Here's the legend that says which color is which value. And it does it for all 30 of the entries. But you don't need to make a bar chart. You can make any kind of plot you want. Here is a scatter plot. And here is nonsense upon nonsense. Here is a line plot, which just looks like garbage. But that's what it is. I've got a lot more to say about pandas below when I get to the SQL section. One thing I'm not going to show is that pandas can get its data in a lot of different ways. It can get data randomly. It can get data from NumPy, which is the underlying array management tool that is written in C that Pandas uses. It can reach out and get the data from SQL. That's what we're going to do in a little bit. But it can also read a web page, find a table on that web page, and read that table into a data frame and let you manipulate it. I'm not going to do that, but it's cool and you can do it. So let's go to a new top-level item, Jupytext. This notebook interface is great, but I don't know about you, editing text in a web page is not really my favorite thing. A Jupyter Notebook is different than just an ordinary web page. It's pretty good. It's reliable. Your text isn't fragile, but you can't do everything that you can do in an editor. So Jupytext lets you convert text between different formats. First, before I go to Jupytext, let me show you that there are some editors that can open notebooks natively. And what I'm going to do is I'm going to bring in my shell, and I'm going to say PyCharm Jupyter presentation.ipy notebook, IPyNB. That's the notebook version. Please open it. And it's going to take just a second as it prepares the worksheet. And I can't make this bigger, I'm sorry to say, but you can see that it understands what the cells are. It draws lines between each cell and will highlight the cells in green to show you what a cell is. And when you get to code, it can actually, I believe it can execute this code. I wonder if it can execute it. Let's find out. Nope. Oh, it looks like it's doing something. Maybe it is executing it. I don't know. Let's not find out. Let's just quit. And then let's open it in Visual Studio Code Insiders. It opens a lot faster than PyCharm. And it also knows the cells and has the markdown pre-rendered for me and knows the execution cells and what's going on. It's not showing the results because I haven't saved, But if you want to edit in an editor, you can use Visual Studio Code or PyCharm. I think there's a couple other editors that also know how to edit notebooks natively, but that's not what I want to do, because I like Vim. I want to use Vim to edit my notebooks. So to do that, I could use Jupytext to convert the notebook to a markdown file. MD is the extension for markdown. And when I had made changes in the markdown, I could convert it back to an IPy notebook. And update would help me keep my metadata. But I don't want to do that. Jupytext is automatic. I can Shift-Command-C, pair notebook with markdown. As you can see, it already has a check because it's already working with me right now. When I have my cell, when I have my notebook paired with markdown, what that means is that here is a markdown file that is automatically updated every time I save this. Let me save my Jupyter Notebook. And that saved both of them. And so now, if I let me Control A, create Vim presentation. That notebook is JSON, which I don't want. And the markdown file is markdown with metadata. Now, later I'm going to show you how to make a slideshow. This file is very busy because it has the slideshow metadata in it. But this is way easier to edit than anything else because I'm good at Vim and I like Vim. Vim is my favorite, in fact. In fact, you probably heard me talk about Vim. And if I make some change to this, it would change in my working version as well, in my actual notebook. But it would make all my cells render, all my markdown cells render, and I don't want that to happen. So I'm not going to make that happen at this moment. All right. That is Jupytext. And the reason you want to use Jupytext is because it's automatic. Diffing is easier. Checking it into version control is easier. Using it in your editor is easier. These are the main reasons, at least for me, why I like to use Jupytext. But if you don't want Jupytext, if you don't want automatic conversion, you can use NB-convert. NB-convert actually goes back and forth between a great many different file types. And it does it by saying Jupyter NB-convert notebook --2 format. And the first thing that we're going to convert it to is slides. So this is a bash cell magic. And I'm going to, right now, show that we do not have slides at the moment. And I'm going to execute this bash cell. And there it wrote some standard error. And there's the slides, which I have to trust to be able to look at them. And then here is the actual slideshow using JS Reveal or reveal.js or something like that. And it has all of the outputs in it. If I get to a cell that has output, here's a cell with output. And it also has the standard out in it as well. So slideshows. You can also convert to HTML, which I'm going to do at the very end to make sure that there's an HTML copy of this presentation for Craig to put on the MUG website. I am not going to execute that right now. You can generate LaTeX, which is great, and I was able to generate LaTeX. I had a little bit of trouble running tech to produce a PDF on LaTeX, and I don't know why. I did not dive deep into it, but that gave me problems running the PDF as well, because the PDF uses LaTeX as the backend. And the complete set of NB convert output types is ASCII doc, custom HTML, LaTeX, Markdown, Notebook, PDF, Python, restructured text, script, I don't know what that means, slides, and web PDF. Let's go to a new top-level item. This is actually my favorite topic of Jupyter Notebooks, and that is IPyWidgets. To get IPyWidgets, first you need to do some things. We're going to draw some graphs, so I'm going to import Matplotlib. I import NumPy to get some random data, and IPyWidgets is the main thing that I'm getting. And the normal thing that you import IPyWidgets as is as widgets. So there we go. Now, widgets define individual controls and web elements that go on the screen. Things like sliders, text fields, buttons, checkboxes, pop-down menus, things like that. The first thing we're going to define is an int slider. It's going to start with the value 7. It's going to go from 0 to 10 by 1. It's going to have the label test. It's going to be enabled. Continuous update, I'm going to explain in a second. It's going to be horizontal, and it's going to show the value. And the readout format for the value is decimal. And display makes it appear on the screen. So here it is. And I can drag it all the way from 0 to 10. It started at 7. And I can display it more than one time. It's the same slider. So if I display it, it's looking at the same underlying model. And so, because I said continuous update is true, they all change at the same time. Now, let's make integer text box. This is a text box with an integer in it. It's going to start with the value 7. It's going to go from 0 to 10, but it's a text field. I'm going to display it, and then I'm going to link it with JSLink from the int slider value to the text value. So now, if I grab this and drag it to 0, the text field goes to 0 too. The text field does whatever the slider does, and the slider does whatever the text field does. Now I'm going to make a button. And that button, which is just going to say click me, and it's going to be in the warning style, that'll make it be orange. It's going to have a tooltip. That button has an onClick. The onClick executes this function, and that function sets the value of my int slider to 9. Right now, the value of my int slider is 2. Let me execute this cell. Now I have a new button, and when I click that button, this slider and this text element are going to jump to 9. Ready? Click. And boom, they're 9. So you can build, so this is just a tiny sample of what you can do. Let me actually hook this up to a graph. I'm going to use a special library that I found on Stack Overflow to make sure this part works. But basically, I am making a plot that depends on an existing control. And that control is W for the amplitude, or for the frequency, and goes from 1 to 10. Can't find IPython. What? Can't find variable IPython. Did I execute everything? Damn it. This was the nice one. I feel bad about this. Okay. Well, that's that. There are tons of widgets. And I'm going to show you the widgets right here. I've already made this one big. But int slider, float slider, they have demonstrations of each of these. I've got a link in the slideshow or in the HTML page, whatever it is that you get, that leads you to this page of samples so that you can see everything. Off, on, off, on, off, valid, invalid. It's a large selection of things. Let me drag the scroll bar and show you. There's a ton of things. These are accordions. The accordions can share values. That's what it's showing here. Here's tabs. Text, slider, nothing. So that is showing you all of the widgets, of which there are many. And I've listed some resources here. There's the IPyWidgets documentation. There's a simple YouTube video, a deeper YouTube video, and a YouTube video about building your own dashboards. So dashboards, for instance, with stocks or with the status of all your valves and hyperfluids and whatnot, or how your assembly line is going, or anything. All right, NB Viewer, a new top-level item. It's built into GitHub and some other source repositories, but it's usable separately as well. It has its own repo here, so you can install it locally and run it locally, or you can use it remotely. I'm going to actually copy this link. Open it in Firefox. And you can see this is a typical GitHub display, but what you haven't seen before is GitHub showing you an IPy notebook, a Jupyter notebook. You can see that the system I used was 3.7.1 because that was 2018. That was before 3.10. I've got links. I've got a big hunk of code that I wrote that highlights characters. I've got regular expressions. This is actually a talk I gave to Mug back in 2018. Is that when I gave it?
I'm not sure, but I could look it up.
I think I gave it in 2018. because that's when it says on the version text. So you can see it's static text. I can't execute it or turn the cells back into code or markdown, but I can see what happened in it and see the things that it actually matched or didn't match and why, according to what my function printed out. All right. SQL. There is a built-in ORM for SQL inside Python called SQL Alchemy. It is known to all Python programmers. They don't necessarily know how to use it, but everybody has heard of it. And I am going to use it to connect to my own Postgres database here that is running on my Mac. And yes, I'm bad. I have no password on my local Postgres database, but I also only have sample data in there. Oops, I hit Command Shift Space instead of. So the first thing I'm going to do is I'm going to do a cell magic, and I'm going to do a selection from food group. This is a nutrition database that I loaded. Some of the tables are small, like this one. The food group table is small, and I'm just going to look in the food group table, and it only has 2 columns and 24 rows. This time, instead of using a cell magic, because I used a cell magic here with 2% signs, I'm going to use a line magic, and I'm going to assign the result to a Python variable, and then I'm going to print that variable. So Shift Enter. Now this appears in a result cell because it's the value of food group simple. It has 24 rows, and let's find out what type it is. It's a result set. That's annoying. We don't want it to be a result set. We prefer pandas. We prefer a data frame or a series. So let's use pandas instead. The first thing we're going to do is we're going to read from the food group table, which is the table we just read from. It's small. Now it has indexes on the food group rows. And if I say, what type is that? Let me actually insert a cell and say type of food group. It is a data frame, and that is what we wanted. So now what I'm going to do is I'm going to read in the big table. The big table has 235,000 rows or something. I'm going to read it in 7 times and time it. And then I'm going to read it in 1 more time and put it in this variable. And then I'm going to print the variable. So 685 milliseconds on average per loop, where a loop just does this read SQL table. It has 254,000 rows. And this is the table with the first 5 and last 5 rows printed. And let's see what type it is. If I knew something about this data, which I don't, maybe I could graph something interesting. Or if I had reached out to an HTML page with a table that was graphable, maybe I'd be able to make a sensible graph, but I didn't do that. All right. New top-level item. NBDev. NBDev is its own whole package. If you want to do literate programming, in a Jupyter Notebook, you want to build full packages that you want to publish on GitHub, publish their documentation in Read the Docs or in GitHub Pages, get your package up onto PyPy, run integrated tests, and get continuous integration, then you use NBDev. NBDev is so powerful. I struggled to figure out what to show you. It does so many things, and most of them require setup and metadata and configuration files. And I didn't want to make any setup or metadata or configuration files, and I certainly didn't want to commit those to our Git repo. So I'm not going to show you any of the details of NBDev, but I am going to say that you can look at it. Let's actually look at an example of literate programming. Comments are the real documentation. Things appear in the order that makes them most applicable to human beings. They're exploring the shape of the output and writing classes that interpret that shape, describing why they do it. This may look to you like just ordinary comments and not something interesting, something different. But when you look at what literate programming is and how they are presenting this, this is really about presenting it to human beings and not to compilers. So it's worth investigating. I have included the homepage for NBDev, a basic tutorial, and an introduction video. In the introduction video, they talk really slow, so I sped it up to 1.25x for me. Maybe you want to do that. I don't know, maybe people who are watching this video want to speed it up to 1.25, but there you go. One thing that NBDev can do is it can turn your notebook into an actual book or an article. It takes configuration to do that, just as it does with Jupyter Books, which I actually prefer. Jupyter Books is a whole nother way to make books out of notebooks, and Jupyter Books is built on Quarto, which NBDev also uses. Quarto is the basis for building books out of both these things, and Quarto can build books by itself. There are many outputs available. The most used among them is HTML for publishing directly to the web, but most interesting to me is EPUB, because I love the idea of publishing to an EPUB reader. But Jupyter Book will publish to GitHub Pages, Netlify, or Read the Docs, or a lot of other things. So how do you install and run Jupyter? So for this demonstration, I used PyEnv to build my virtual environments, but it will be similar if I used venv or virtualenv. Here's what I did. Let me bring my app over, and I will, oops, my fingers are on the wrong keys. Maker notebooks, cd notebooks. Now I will make a new virtual environment, PyEnv, virtualenv. Python I want to use is 3.10.5, and I want to call it Jupyter Notebooks. It just built that. So now if I say PyEnv virtual envs, it lists Jupyter Notebooks as one of them. And here's Jupyter, the one I'm using in my demonstration notebook. So now I say PyEnv local. That means for this project, whenever you're in this directory, use Jupyter Notebooks. Now you can see I am using the virtual environment Jupyter Notebooks. And so the next thing I need to do is install some stuff in the Jupyter Notebook. Installing stuff.
While we're waiting for installs, is there any questions out there? Or are there any questions, I should say? Feel free to raise your the raise hand icon at the very bottom.
I feel bad about not being able to show that graph that moves. That I worked very hard on getting that to work, and then the fact that it doesn't show up made me unhappy.
Well, it looks like JavaScript is having some issues.
Yeah.
Go figure.
LXML takes just a second.
It's actually building LMXML. Or
It is actually it's running setup for it, which builds the wheel, I think.
Okay.
But
Yikes.
now it's done, and it's going to be finished with everything in just a second.
Oh, right, because you probably don't have an M1.
This is an M1.
Oh, yeah. Yeah, but then I don't think there's an M1 wheel for it quite yet.
Correct. That is correct. Come on, be done. Of course, when I want it to be done, it's not. There we go. So now I've got everything that I want. I'm already running Jupyter over here. You can't see, but I'm running it on port 8888. So if I run a new Jupyter notebook, Jupyter lab minus port equals 8889. Here we go. And it started a new lab with all my kernels already installed. I can make a new one in whatever language I want. JavaScript. I think I've got interpolation right here. Nope, I don't. But I am running an entire instance of Jupyter Notebook here. And to get rid of Jupyter Notebook, you hit Control-C, and then you're done. And to get rid of your virtual environment, RM minus RF notebooks and IN uninstall Jupyter Notebooks. Yes, please remove that one. Now we're back to where we were before. You can install it globally instead of putting it in a virtual environment, and I strongly admonish you not to do that. In Python, you should always use a virtual environment, not just for Jupyter, for absolutely everything. Nothing global. And the reason is, if you install global stuff, it will stomp all over itself. You'll install packages at one version, and then you'll install them in another version, and then something that uses the first version will break. It's terrible. Installing with Anaconda. Now, I don't have Anaconda installed. Anaconda is a distribution of Python, and it includes everything a data scientist could want. So it's very large. It comes with a lot of stuff. And Jupyter is part of Anaconda. You don't need to install anything. Jupyter just works out of the box with Anaconda. You can install using Docker. I'm not going to show that either. I did list a tutorial on running Docker and installing Jupyter, but I don't have Docker installed on this machine because when I did have it installed, it was eating up CPU while doing nothing. So I uninstalled it because I could not tolerate that. You can install kernels for additional languages. Now, I've already got the bash kernel installed, so I'm not going to install it. But basically, usually it's a two-step process. You get the kernel somehow, and you install it. And each one of those is a one-step statement. This, it turns out, you can do entirely in bash with pip and Python. Some you have to do in their own language, like to install Racket, you have to use the Raco packaging tool to get the kernel and then make it run. I'm not going to install a kernel now, but it's easy to install the kernels that you want, and it's going to come with Python as a built-in default kernel, and you can have whatever you want. The only kernel I had problems with was Perl. But remember, you don't need one of those special kernels if you're going to use magics. If you're going to use a script magic to get bash or JavaScript or Perl or whatever, they just require bash or Perl or the browser to be installed natively on your machine. That's all they want. We talked about running Jupyter, and we didn't talk about tmux, but I always use tmux. And finally, what did I talk about? I talked about what a Jupyter Notebook is, that cells are code or markdown or raw. Code cells can be executed, what line magics and cell magics are, pandas and matplotlib, Jupytext, NBConvert, building GUIs with IPy widgets, NBViewer, like at GitHub, SQL, NBDev and writing literate programs, and how to install and run Jupyter. And now I am ready to take any questions and or modify this notebook in any way that you want to make new things happen. How can I answer your questions?
Gib has a question. Go ahead, Gib.
So in my environment, I've had some people, some data scientists, like 100, 200 of them coming in and using Jupyter Notebook. And we had to set it up so each individual student or participant had to have their own copy of everything, and that was administratively cumbersome. So I'm wondering if it is possible, reasonable to be able to share a notebook, share an environment with all the data and code and things like that, and have multiple people using it.
There is a beta feature in notebooks called collaboration. I don't know anything about it besides that name, but it sounds like it may be interesting and applicable to your situation.
Okay,
Another thing that might be useful to you is that you can use the cell magic or the line magic %pip to install things. So if they can just get Jupyter installed, they can %pip install everything else, and you can put that in the notebook that they start with.
Okay, thank you.
I don't know which of those is more helpful, but surely one of them might do something.
Yeah, well, so getting someone to understand pip and things like that might be more than I want to, take on. But okay, thank you. I'll take a look at that. Thanks.
I hear you. Other questions?
Go ahead and use the raise hand feature if you want to ask a question, please.
I guess I'm going to call it. I'm going to make this into a NB.
Robert, you have a question. Go ahead.
I do. Thanks. Wolf, very nice presentation.
Thanks.
You covered. I mean, I'm actually fairly familiar with Jupyter Notebooks, but you covered stuff that I didn't know. So this is really nice. Every time I see a presentation, I learn something new. There's so much going on with it. Your particular presentation as a notebook, will you make it available via either a website or via GitHub or something else?
I'm going to do that right now while you watch.
Wonderful.
And this is one thing that's nice about Jupyter Notebooks is that it's a very portable way of sending data to other folks. So it's not, you know, if you've got something like a CSV file or something, great. But if you have something that needs a little more presentation around it or a little bit more code, it's definitely a good way to get all of that stuff situated so that other folks can take a look and verify your work. Especially since Excel does some very interesting things when it comes to formulas and whatnot. I remember an article a long time ago about non-repeatable data in Excel because Excel did something very funky and things got weird. I think that's part of the reason that data scientists like to use it is because you can shovel it massive amounts of data in an IPython notebook, or I'm sorry, Jupyter Notebook. I still, to this day, am always calling it IPython notebooks, but it's not the same.
Okay, so github.com/wolf/Jupyter presentation. It is now available on GitHub. And I have produced the HTML file right here. So I'm going to give this HTML file and the notebook to Craig.
Okay, I'll get up on the site as soon as possible.
Thanks, Wolf. I just forked it.
That was quick. Any other questions out there?
Again, this is Robert. Not so much a question, but you know, one of the nice things again about Jupyter is, you know, you had issues with that that Pi widgets. I don't know if I'm saying that right. The iPi widgets. What's cool is now that you've got it on GitHub and I've forked the project, I can now try it on my system, see what's going on, and then if I figure it out, issue a pull request and say, hey, this is how you get it to work, or what have you. So I think Gib was asking one of the questions of, you know, how do you share notebooks? That is a way to do it. You know, obviously one of many ways. Obviously, if you have a shared file system, you just copy it. You know, USB sticks work and so forth.
Yeah. I am so disappointed in that graph I couldn't draw. I wonder if I go back and close this notebook.
Was someone just faxing something just there?
Yeah, cutting edge technology. Come on.
Oh, no, definitely. I mean, it's good enough for the medical industry, right?
Oh, God. Yes, it is.
Yeah. And lawyers. Any other questions out there?